So scientists like to classify things. It helps us to organize lots and lots of information. And just like you can classify, say, Lego bricks in different ways, you can sort them by color, or you could sort them by size or shape or what set they came with. We can sort molecules in different ways. One way to classify organic compounds, which is what we're talking about this class, is by their molecular framework. And so if we do it by their molecular framework, we end up with three main classes. Acyclic. A is a prefix meaning without, and that means these compounds contain no rings. The carbon chains could be straight or they could be branched, but there are no rings or loops in them. Carbocyclic compounds contain rings of carbon atoms, and heterocyclic compounds contain rings which have at least one atom that is not carbon. Hetero is a prefix that means different. Carbo refers to carbon. So carbocyclic, cycles or rings of carbon. Heterocyclic, more than one kind of atom in there. And we'll look at some examples here. This is an acyclic compound. All three of these are. And you see that here's a chain of carbon atoms. These are condensed formulas. When we see the CH2 in parentheses with a 5 on the outside, I didn't really cover that. That means that if you were going to draw it out in less condensed, you'd put 5 CH2s. So there's 2, 3, 4, 5, and then the CH3 at the end. So these are exactly the same. So you'll see that frequently. And here's another one. There's 4 CH2 groups just right in a row is what that means. So those are acyclic. These are naturally occurring carbocyclic compounds. This is made by musk deer. It's a compound called muscone, and it's got a many-membered carbon ring. Each of those points is a carbon atom. Benzene, here's one that some people really like, testosterone. This has multiple rings. But what's common to all these carbocyclic compounds is that the rings only contain carbon. This has oxygen, but it's not part of the ring. In the heterocyclic compounds, we'll see other elements such as nitrogen present in the ring. I guess these examples only have nitrogen in the ring, but some of them have more than one nitrogen. This is penicillin G. It's a widely used antibiotic. We can also classify according to functional group. And this is a more useful type of classification. What do we mean by functional group? A functional group is a group of atoms that have a characteristic or a group of characteristic chemical properties that don't really depend on what that group is attached to. And so when we group by functional group, we see that members of this different groups are going to have similar chemical properties, and that's a really helpful thing. So these are the main functional groups. You should begin to become familiar with them because you're going to need to know all of them by the end of the semester. So here we have alkanes. These functional groups are actually part of the molecular framework. This is the carbon-carbon single bond, carbon-carbon double bond, triple bond, and this is called an aromatic compound or an arene, and it's got alternating double and single bonds in a ring. And we'll talk more about all of these. There are functional groups containing oxygen. If we've got an OH off of a carbon, that's an alcohol. When we've got an oxygen by itself sandwiched between two carbons, that's an ether. And there are specific examples over here of showing you what that might look like in a compound. So here's the oxygen sandwiched in the middle. Here the oxygen is between the carbon and the hydrogen. When we look at these structures over here, these lines mean that something is connected there. It could be almost anything. Carbons, hydrogens, oxygen, well, not oxygens, but any sort of any sort of carbon or hydrogen. Here we have oxygen with a double bond, and that's called an aldehyde when it's on the end. It's called a ketone if that carbon-oxygen double bond is found in the middle of the molecule. We can have double and single carbon-oxygen bonds. We get something like this, we have a carboxylic acid. If it's sandwiched in the middle, it's called an ester. So we've got the same double bond oxygen, single bond oxygen in the middle or at the end, and that affects the chemical properties of these compounds. And we're going to go through each of these classes of compounds and talk about them. There are functional groups that contain nitrogen. This is a primary amine. This is a nitrile group. Oxygen and nitrogen together we have a primary amide. We can have halogens on here. X usually stands for halogen, either chlorine, fluorine, bromine, or iodine. And then there are sulfur-containing groups, thiols and thioethers. So you should begin to become familiar with those, but we will go over them. Here's some examples, and I don't know that there's a lot of benefit to me talking much about these because we're behind. I guess the only thing we could say is, here is an illustration, a generic example, and here's a specific example, and we should be able to pick out this functional group when we look at this big molecule. This has this ether functionality here, but it also has an alcohol group. And so some compounds have more than one functional group on them, and that affects their chemical properties. Yes?
I figure, what does it mean if there's lines in the octagon? Or what is it?
Double bond.
The second line here?
Yeah.
That's a double bond.
Okay.
So we can have double bonds within that ring.
Okay.
That's a good question. This is the chemical that makes cinnamon smell like cinnamon. This functional group is called an aldehyde, and we see that right up here. This is the aldehyde functional group. So those are interesting and all, but this is not specifically covered in the textbook, but might be helpful. This is the hybrid orbital that we talked about, which is a combination of one s and 3 p orbitals, and so we call that sp3. And that will give rise to a tetrahedral shape if you have atoms on each of those things. You can also combine an s with 2 p orbitals and get an sp2, or an s and a p and get an sp. And so these names of the hybrid orbitals just tell us how many of each type of orbital are combined.